Capstone Slideshow Final Project. My name is Charles Bunting, and today I'm going to present the results of my analytic research project on crosswalk safety on Fort Myers Beach. The purpose of this paper will be to determine the best pedestrian traffic control device to install on the 27 crosswalks on Fort Myers Beach in order to increase pedestrian safety by encouraging drivers to yield to pedestrians in the crosswalk. First, let me tell you a little bit about the town of Fort Myers Beach. Prior to 1995, Fort Myers Beach was part of an unincorporated Lee County. In December 1995, the town of Fort Myers Beach was created after a referendum was passed by the residents. The town is run by a town council consisting of a mayor, a vice mayor, and 3 council members. In addition, the town employs a town manager, an executive administrative assistant, a town clerk, a contracts manager, and a receptionist, with an annual budget of over $28 million generated from taxes. In addition to the staff and council members, the town has the following departments: Community Development, Environmental Sciences Division, Finance Department, Public Works Department, and Parks and Recreation Department. The town's jurisdiction includes approximately 2.9 square miles of land and an area of water extending 1,000 feet from the shoreline. The population of Fort Myers Beach was 6,561 people in the 2000 census. According to the Town of Fort Myers Beach website, the population density is 1,456 persons per square mile. The median age for residents is 59.1 years. During the season, which runs from November through April, the population increases dramatically. Some estimates increase the population to over 30,000 visitors during the season. Estero Boulevard has one transportation corridor known as Estero Boulevard. There are 3 main business clusters on the island. The downtown area is located right over the bridge in a section known as Times Square. Another cluster stretches down Estero to include Town Hall, Bay Oaks Recreation Center, the Beach School, Seagrape Plaza, and the library. At the south end of the island is Santini Plaza, which houses restaurants, clothing stores, a hardware store, and laundromat. Across from the plaza is a very busy CVS pharmacy and a Holiday Inn. Along Estero, at the north end and south ends of the island, are many high-rise residential buildings. Fort Myers Beach is a tourist town that draws people from all over the country. From November through April, the population increases from 6,000 residents to over 30,000. Estero Boulevard is a 1-lane road and can only handle so much traffic. In the past year, at least 4 pedestrians have been killed while crossing Estero Boulevard at crosswalks. Last year, a Wisconsin woman was hit and killed while crossing Estero at a crosswalk near CVS. The driver of the SUV that struck her says he didn't see the woman until it was too late. Less than a year later, an Ohio couple was struck at a crosswalk across from Bay Beach. They were crossing from the beach to the bay side of the street at a crosswalk when they were struck by a minivan that was traveling 25 miles an hour. The driver of the van said that he saw the couple in the crosswalk, but it was too late for him to stop. Later that year, a visually impaired woman was struck while crossing in front of the Holiday Inn. These accidents have made the town council aware of the increasing traffic issues on the island. According to Larry Kiker, former Fort Myers Beach mayor, there were 24 pedestrian accidents last year alone. Fort Myers Beach is a tourist town that draws people from all over the country. From November through April, the population increases from 6,000 to over 30,000. The town has one road known as Estero Boulevard, which is 1 lane and can only handle so much traffic. The root cause of this problem is the traffic and limited infrastructure on the island for dealing with the traffic. Traffic on Fort Myers Beach has been an issue since the 1960s, when the swing bridge would open for shrimp boats, leaving traffic backed up for miles. The new bridge was completed in the 1980s, but with the increasing population, the traffic problem still exists. Estero Boulevard is the only road on or off the island, so there is no room for error. Traffic backs up for miles and drivers get angry. Pedestrians are on vacation and are not paying attention when they cross the road. They walk out in front of traffic thinking the drivers will stop because they are at a crosswalk. Likewise, many drivers are also on vacation and are looking at their surroundings rather than paying attention to what is going on in the crosswalks. The problem affects many different stakeholders. First of all, it affects the people who live on the island and the people who visit the island, since they are the people who are endangered by the unsafe crossings. However, it also affects the town council and the town officials who are responsible for the safety of the residents. Estero Boulevard is owned by Lee County, so they are also affected by the problem. The businesses are affected because people may stop coming for vacation if they feel the road is unsafe. All of these stakeholders are working together to find a solution because it is in their best interest financially as well as ethically to make sure the road is safe for pedestrians. As a part of this project, I studied 3 other cities that face similar situations. Miami, Florida has one of the highest pedestrian fatality rates in the state. Over 50% of those involved in pedestrian accidents in Miami are over the age of 55. In order to improve the safety of pedestrians in the city, the University of Florida worked with the Federal Highway Association to come up with some solutions to this problem. The research teams look at many different countermeasures that they could use in the city to help make it a safer place for pedestrians. Some of the countermeasures studied were known as intelligent transportation systems. These included such devices as intelligent video pedestrian detection devices and rapid flash beacons. The researchers also studied smart lighting at crosswalks and pedestrian countdown timers. Other approaches were using smart no right turn on red signs and speed trailers. The results showed that some of the countermeasures worked very well, while others had no significant effect on the behavior of the drivers or the pedestrians. One example of a relative low-cost improvement is using a push button that confirms when the signal is activated. This lets the pedestrians know that they must wait until they see a walk sign before they try to cross the road. This simple low-cost addition to adding to existing crossing signals increased the number of times that a pedestrian actually pushed the button from 33% to 58% at site number 1 and from 40% to 50% at site number 2. Another city that had a similar problem was Seattle. Even though Seattle, Washington ranks as one of the safest cities in the United States for pedestrians, the city was not happy with the fact that 398 pedestrians were killed from 2000 to 2009. In order to address this problem, the city evaluated all of its crosswalks and decided to install overhead crosswalk signs at their busiest intersections. This study showed that these overhead signs were effective in increasing the number of drivers who yielded to the pedestrians in the crosswalks. Before the signs were installed, the drivers' yielding rate was 45%. After the signs were installed, the driver yielding rate went up to 52%. The crosswalk signs were also effective in improving the behavior of the pedestrians in the crosswalk. Before the signs were installed, 58% of the pedestrians ran, aborted, or hesitated in crossing the road. After the signs were installed, this rate went down to 43%. The study also showed that the signs had no effect on whether or not pedestrians actually used the crosswalk. City officials feel that these signs were well received by the citizens of Seattle, and they plan to add more signs to intersections that need improvements. A final case study that I examined was Lakeland, Florida, where 13 pedestrians were killed last year alone. One way the city has tried to improve the safety of the pedestrians in crosswalks was to install a traffic control device known as flashing crosswalks. This device embeds lights into the roadway on both sides of a marked crosswalk. When a pedestrian approaches the crosswalk, he or she will see the button to push that will turn on the flashing lights. The flashing lights are designed to warn approaching drivers that someone is waiting to cross the road. This system is considered better than some other systems that use lights that are flashing all of the time. Since these lights are only on when someone is crossing, the drivers are less likely to become immune to the flashing. The study showed that the flashers were effective in increasing the number of drivers who yielded to pedestrians. Before the flashers were put in, the percentage of drivers who yielded to pedestrians was 15.8%. After the flashers were installed, the rate went up to 41.0%. The study concluded that flashing crosswalks in Lakeland showed a positive impact on the number of drivers who yielded to pedestrians as well as the number of pedestrians who actually used the crosswalk. In addition to these 3 case studies, I also completed an extensive review of literature related to crosswalk safety. One of the most quoted studies was done in 2000 by Hengs, Ziegler, and Nazi, who studied 3 different traffic control systems at various locations to find out what devices worked best. The study included safety cones that were used in New York State, pedestrian flashing amber beacons, and stop for pedestrian signs put in crosswalks. The device that produced the most consistent results in the study were the pedestrian safety cones. Before the cones were installed, 69.8% of drivers yielded to pedestrians in the crosswalk. After the treatment, 82.1% of the drivers were yielding at the crosswalk. In order to come to a conclusion regarding the effectiveness of marked or unmarked crosswalks, the Federal Highway Administration sponsored a study in 2001. The purpose of this study was to find out if it made any difference to have a marked crosswalk. A second objective was to come up with some recommendations that would improve pedestrian safety in crosswalks. This was a large study that examined 1,000 marked crosswalks and 1,000 unmarked crosswalks in 30 cities in the United States. Researchers at each of these 2,000 sites gathered data during the study. All of the marked crosswalks had a marking pattern of some type, but they did not have any pedestrian traffic control devices. After analyzing the data, researchers concluded that there really was no significant difference in pedestrian accidents in marked or unmarked crosswalks on 2-lane roads. This study makes it clear that simply using a marked crosswalk without any additional traffic control measures did not increase the number of drivers who yielded to the pedestrians who were trying to cross the street. However, there was a significant difference in the number of people who used the marked crosswalks as opposed to the unmarked crosswalks. The Federal Highway Association conducted another study which was called the Pedestrian Safety Countermeasure Deployment Project. Using pilot projects in 3 cities, San Francisco, Miami, and Nevada, the study was designed to evaluate the effectiveness of different methods used to improve citizen safety in crosswalks. These were called countermeasures. San Francisco, Miami, and Nevada were chosen as the test cities because the city officials admitted they had problems with pedestrian safety. They also understood how important it was to use data to make decisions. The countermeasures that were studied included the following: automated video detection of pedestrians, flashing beacons, in-street pedestrian signs, and median refuge islands. The study lasted 6 years. This study concluded that certain countermeasures were more effective than others. The most effective traffic devices were rectangular rapid flashing beacons, in-street lighting, pedestrian countdown signals, call buttons that tell the pedestrian that they can cross, and a combination of high visibility crosswalks, advanced yielding markings, and yield here to pedestrian signs. Each of the alternatives was more effective than a normal treatment of zebra stripes and warning signs. Other measures were evaluated as having medium to low effectiveness. These included a portable speed trailer set up in advance of the crosswalk warning drivers to yield, advanced yield markings, and signs on the pavement reading "Look" or "Turning Traffic Yield to Pedestrians" or "Pedestrian Zone." And Du et al. Concluded a study for the FHWA in order to identify and quantify the effectiveness of selected medium to low-cost strategies in improving safety for pedestrians and bicyclists. The author wanted to identify some countermeasures that could be installed in crosswalks to make them safer for pedestrians and for cyclists. The countermeasures selected for the study were the rectangular rapid flashing beacons, the pedestrian hybrid beacon, also known as the high intensity activated crosswalk, shared lanes marking for bicyclists, and crosswalk marking as viewed by drivers. Bartlett et al. Produced a study called Proving Countermeasures for Pedestrian Safety that looked at different ways to reduce the number of pedestrians who are killed each year in the United States. Two proven countermeasures included medians and pedestrian refuge areas and walkways. This report clearly indicated that using medians and walkways can reduce the number of pedestrians who are killed or injured each year. For this research project, I chose 4 possible traffic control devices to study. The first device was the rectangular rapid flashing beacon. Rectangular rapid flash beacons can be very effective when they are installed in a crosswalk that does not have a signal. The rectangular rapid flashing beacons contain 2 LED flashers that are 6 inches wide and 2.5 inches high. The distance between the 2 flashers is 9 inches. These LED flashers are on each side of the device. The LED on the left side will flash twice very slowly. Immediately after the left side flashes, the right LED will flash 4 times rapidly. This flashing pattern catches the driver's attention because it is not a pattern that one would expect. It is like a stutter flash effect. This irregular pattern is very much like the flash pattern that is used on emergency vehicles, so it is familiar to the drivers. The rectangular rapid flash beacon system has been effective. An FHWA study conducted in St. Petersburg, Florida, found that this device was much more effective at increasing the number of drivers who yield to pedestrians than traditional overhead beacons. Another benefit of this type of system is the cost. The cost to purchase and install 2 units is approximately $10,000 to $15,000. The second alternative that I studied is known as the Hawk Crossing. This system is based on a European special design. It is also like the school bus warning system that is used in America. The Hawk uses a standard crosswalk signal, which is 2 red lights over 1 yellow light. The lights remain dark until a pedestrian pushes a button. Once the button is pushed, the system is turned on. The yellow light is the first light to start flashing. The yellow light then changes from a flashing yellow to a solid yellow. This alerts the driver to prepare to stop. Next, the two red lights come on. Pedestrians see a flashing sign that says it is okay to walk. After a certain amount of time, the don't walk sign lights up and a countdown signal is shown, which tells the pedestrians how much time he or she has to cross the street before the don't walk sign appears, and along with a countdown signal telling them how much time they have left to cross the street. Although overall the Hawk system had favorable reviews, there were a few issues that made it less favorable than the RRFB system. The first problem is related to the dark beacons. If the signal is not activated, the lights remain off, and there is some concern that drivers may see this dark signal and think that it is a traffic light that is not working. This might cause them to stop abruptly when it is not necessary. Another downside to this system is the high cost of approximately $80,000. The third type of pedestrian crossing device is the raised median or refuge island. The area between lanes of traffic is called the median. There are many different types of medians. Some medians are marked only with paint or tape. The cost of a raised median can be anywhere from $15,000 to $30,000 per 100 feet. This depends on the design of the median, the location, and whether the site is part of another street improvement project or will be a standalone installation. The cost of a refuge island again depends on the complexity of the design. The range is from $4,000 to $30,000 depending on what landscaping or other barriers are used. Flashing crosswalk is another method I studied to improve safety in crosswalks. According to Godfrey, 1999, this system is comprised of a series of flashing light units installed just below the pavement surface along the crosswalk lines and facing traffic. The purpose of this device is to warn the motorists that there are people who want to cross the road. This system is used only at crosswalks that do not have other control devices installed. The cost for these systems runs from $15,000 to $18,000 each. A before and after study was completed to determine if the devices had any effect on whether or not drivers yielded to pedestrians in the crosswalk. The study was done in Kirkland, Washington, and found that the flashing crosswalks were effective in getting the drivers to yield to pedestrians. At one of the crosswalks in Kirkland, the yielding rate went from 16% to 92%. At night, the yielding rate went up to 100%. The device performed in a similar fashion at 10 other intersections in Kirkland. The study concluded by stating, the concept of flashing amber lights embedded in the pavement at uncontrolled crosswalks clearly has a positive effect in enhancing a driver's awareness of crosswalks and modifying driving habits to be more favorable to pedestrians. The purpose of this analytical research project is to provide the best possible solution to a problem in a public service organization. This study is designed to use a quantitative methodology to select the most effective traffic control device to improve pedestrian safety in the crosswalks on Fort Myers Beach. This comparative analysis will determine which of 4 traffic devices presented will be the best choice for the town of Fort Myers Beach. Each of the alternatives was rated in 4 categories: legal, financial, organizational, and political. 11 different outcomes were evaluated on a 5-point scale. The alternative with the highest score was the flashing crosswalk, which scored 172 points. The next highest was the rectangular rapid flash beacon, which scored 166 points. The Hawk Crossing and the raised medians scored 146 and 145 points respectively. The implementation of the flashing crosswalk system can be accomplished over the next 3 years if the following plan is implemented. Year 1. First of all, the town needs to work with the county engineers to deal with the technical issues involved in traffic device installation. Steve Jansen is the engineering manager for Lee County, and Rob Phelan is the senior engineer for Lee County. The engineers would first need to take an inventory of the present crosswalk system, which is a combination of 4 different systems. Many of the crosswalks are only marked with zebra stripes, which have been proven to be less effective. The way the crosswalks are set up at the present time is confusing for drivers and pedestrians since they employ different systems. All of the present systems should be removed, leaving only the zebra stripes. This would make the crossing consistent for the next step in the process. Once all of the crossings are the same, a traffic team should be set up to determine which of the current crosswalks would warrant a flashing crosswalk signal. This team should consist of engineers from the county as well as the town. A traffic research group might be consolidated to train the team in the best way to carry out the study. This study will be designed to help the town decide which of the current crosswalks will get the flashing crosswalk treatment. A treatment and matched comparison site methodology will be used to determine which crosswalks are the busiest and will be considered for treatment. The study will include pedestrian crash history at each site, average daily traffic volume, speed limit, and location. At each of the 26 crossing locations, trained data collectors will observe pedestrians and classify them by age group. Pedestrian counts will be collected for 1 hour at each of the locations at the same time of day. Full 12-hour counts will be conducted at sample sites that are randomly chosen. This data will be analyzed to determine which 10 of the 26 crosswalks will receive the treatment. This part of the plan could be implemented immediately. The first study will be conducted during the off-season from August through October. The second study can be conducted during the 2013-2014 season from November through May. Year 2. Once the study is completed, the data will show which 10 crosswalks will receive the treatment. The Lee County Board of Commissioners is charged with maintaining Estero Boulevard, so they need to be a partner in this entire project. One recommendation based on research would be to lower the speed limit to 25 miles an hour in certain designated walking districts on the island. A lower speed limit would increase the effectiveness of the flashing crosswalk signal. Now the town would need to figure out how to fund the project. At a cost of $30,000 for each crosswalk, to fund the 10 crosswalks would cost the town $300,000. Since Lee County is responsible for maintaining Estero Boulevard, the council will need to ask them to split the cost. Then the council will need to put $150,000 into the budget for the purchase and installation of the flashing crosswalk systems. This could be easily accomplished without raising taxes. The next step would be to purchase the crosswalk systems and have them installed at the chosen locations. Mr. Michael Harrison invented the flashing crosswalk system, and his company Lightguard has been building the systems since 1994. Year 3, by the end of the second year, all 10 of the selected crosswalks will have had the treatment installed. Now would be the time to evaluate the effectiveness of the system and to look toward the future. Once the 10 crosswalks have been installed, the town would conduct another study to determine the effectiveness of the flashing system. Using the untreated crosswalks as a control group, the trained volunteers will observe all crosswalks. The purpose of these observations is to observe and record the behaviors of the drivers and the pedestrians as they interact with the crosswalk systems. The people who are doing the observations should set up a scale whereby they can observe and measure certain behaviors. One of the most important observations would be to record the number of drivers and the pedestrians as they interact with the crosswalk systems. The people who are doing the observations should set up a scale whereby they can observe and measure behaviors. They will record the number of times a driver yields to a pedestrian, and they will record the number of times a driver or a pedestrian is forced to take some kind of evasive action to avoid an accident. Once the study has been completed, the data will be compared and analyzed to determine the effectiveness of the treatment. The team also needs to do a thorough study of the accidents that have occurred in the crosswalks over the past 5 years. This would include pedestrian accidents as well as vehicular accidents. This information could be provided by the Sheriff's Department. I would like to thank you for taking the time to listen to my presentation. Pedestrian safety is an issue that is important to everyone who lives on or visits Fort Myers Beach. I hope this information will help you to make the best decision to improve pedestrian safety on Fort Myers Beach. Thank you.